Today, we're diving into the incredible art and science of steganography. It's all about hiding secrets right out in the open. You see, this isn't about locking a message in a box. It's about making the box itself completely invisible. Think about it like this. With normal encryption, an outsider can at least see that there's a scrambled message. They might not be able to read it, but they know something is there. But what if you could send a secret that nobody even knew existed in the first place? That's the whole game with steganography. So what is it exactly? Well, steganography is the technique of hiding one piece of data inside another. It's kind of like the digital world's version of invisible ink, where a file that looks totally innocent, like a vacation photo or your favorite song, is actually carrying a secret. All right, so let's start with the basics, the most intuitive forms of this. We're going to look at how something as simple as a text file or an everyday picture can be turned into a digital secret compartment. Hiding data can be surprisingly simple. In a basic text file, you could use something like extra spaces between words, or maybe a specific pattern of capital letters to encode a message. The big advantage? It's super simple. You don't need any extra files. But, and this is a big but, the trade-offs are huge. The amount of data you can hide is tiny, it's pretty easy for software to detect, and if someone just reformats the text, poof, your secret message is gone. And that is exactly why images are the most popular way to hide messages. Think about it. A modern digital photo has millions of pixels, and our eyes just aren't good enough to notice tiny, subtle changes in color across all of them. That built-in redundancy makes images the perfect camouflage. So how in the world does this actually work? Well, the most common technique is called the least significant bit method, or LSB. Here's the deal. Every single pixel's color is defined by a string of ones and zeros. The LSB method is brilliantly simple. It just takes one bit from the secret message, a 1 or a 0, and uses it to replace the very last bit of a pixel's code. The change to that pixel's color is so small, so insignificant, that it's completely invisible to our eyes. But you do that over and over again across thousands and thousands of pixels, and suddenly you've hidden an entire file. Okay, but we can take this way further. If you can hide data in a static image, it only makes sense that you could also hide it in files that are constantly in motion, right? I'm talking about audio and video. The same basic idea works for sound. Just like a picture is made of pixels, a digital audio file is made of thousands of individual sound samples every second. So, audio steganography works by making these tiny, calculated adjustments to those samples. The changes are so subtle they just get lost in the natural noise and complexity of the sound, which makes them totally imperceptible to the human ear. You could be listening to your favorite song with no idea it's also carrying a secret message. And that brings us to the ultimate carrier, video. A video file is really just a huge container. It's packed with thousands of image frames, plus one or more audio tracks. This combination gives you an enormous amount of space to hide data, which makes it incredibly powerful and extremely difficult to detect. When you look at the capacity, the difference is just staggering. A text file, it can barely hold anything. An image gives you a massive leap forward. But video is in a completely different league. It offers this enormous digital space where you can conceal even really, really large files. So far, everything we've talked about involves hiding data inside of files. But what if you could hide data in the way files are sent? This is where it gets really mind-bending. This is network steganography, the true ghost in the machine. Right, so instead of hiding a secret inside a digital envelope, this method hides it in how the envelopes are sent across the internet. You're building a covert channel from the traffic itself. For instance, think about sending letters through the mail. You could send a secret just by slightly delaying certain letters. That's kind of like altering packet timing. Or you could change the order in which the letters are delivered. You could even use a secret code in the to and from addresses on the envelope, which is similar to manipulating the data headers. You're not changing the letter inside at all. You're using the delivery process itself to communicate. It's unbelievably subtle and almost impossible to spot unless you know exactly what you're looking for. Okay, so this is all fascinating stuff, right? We know what it is, how it works, but so what? Why does this technology actually matter in the real world? Well, it turns out it's a very powerful, double-edged sword. On the one hand, it has some incredible positive uses. It's great for secure military communications, for embedding digital watermarks to protect copyright on a photo, or even to help journalists and activists in repressive regimes get data out covertly without raising any suspicion. And this brings us to the core trade-off. The biggest benefit is plausible deniability. A hidden message just doesn't attract the same kind of attention that an obviously encrypted one does. But on the flip side, it's fragile. Simply compressing that vacation photo could completely destroy the secret hidden inside. And of course, that same deniability makes it a powerful tool for anyone with malicious intent. It really all boils down to this one simple, powerful idea. Encryption is about making a message unreadable. Steganography is about making the message itself undetectable. Its real power is in its total invisibility. And that kind of leaves us with one final thought. Every single day, we are surrounded by millions of images, videos, and songs. In a world practically drowning in data, it really makes you wonder, how many secrets are hiding right there in plain sight?